Okay, this problem when they want you to find the volume of the solid generated by revolving the regions bounded by the lines y equals e and the curve y equals e to the negative 1/11th x, y equals 0, x equals 0, and x equals 11 about the x-axis. So let me get my pen. Okay, and so what you're going to do, you want to think about that graph. It doesn't, you can type it in your calculator, but that's the exponential function just decreasing. When x is 0, e to the 0 is 1, so it kind of comes in here, and then it's just going to, it comes in like this, and at some point here they want you to stop it at x equals 11, so it's going to have that shape. And what you're going to do is you're going to revolve that shape around the x-axis, so you would come in like this. So you should think of this as discs marching along the x-axis, which means you will integrate along the x, so from 0 to 11. And you need to get the length of the radius, which of course is just going to be the height there, which is just the y value in terms of x, which is e to the negative 1/11th x. That's your radius. You'll put a pi out in front. You'll have e to the negative 1/11th x, and then that's going to be squared dx. Now remember, when you have an exponential, a power to a power, you're just going to multiply. So this is really like thinking of pi times the integral from 0 to 11 of e to the negative 2/11th x dx. And then you're just going to want to do a nice little u substitution there. If you let u equal negative 2/11th x, then du is going to be equal to negative 2/11th dx. So if you solve for dx, which is right here, you're just going to get 11 over negative 2 du. So you can do that 11 over negative 2, that's what you want to, the constant that you're going to put in front is going to just go in front here. So you have negative 11 halves pi. And then now changing your limits of integration, when x is 0, u is also going to be 0. But when x is 11, notice that that will cancel here and you'll get negative 2. And then this will just be e to the u du. And that's not too bad to integrate. Let me see if I can get some more room here. Let's just figure out how to do this so that I can get, without having to go back in like that. Okay. Okay, now remember e to the u, the integral of e to the u is just e to the u. So you have negative 11 halves pi times e to the u evaluated from 0 to negative 2. Okay. And then you just pop that stuff in. So this is negative 11 halves pi, and then this will be e to the negative 2 minus e to the 0, which is just 1. And so that's just the answer that they want, because they want it inexact. And so you'll see that that's what I got. When I typed it in, they did say it was correct. So that was a fun one. Just remember this u substitution that you have to do here. U equals negative 2/11th x. And then when you take the derivative, you get du is equal to negative 2/11th dx. So solving for dx, you get 11 over negative 2 du. So that was the 11 over negative 2 is a constant, so it's brought it out in front, and then we put the du. Okay, that was fun.